There's no 6 years. That's how I was
Alright, we're going to look at conditional probability. So conditional is this given stuff. So we're looking at the given formula. So the probability of A given B. Remember we talked about anything after this vertical bar, like you know that's true. And we've done it like on charts and Venn diagrams, but you can actually use a formula too, so that's what this worksheet is looking at. So if I look at number 1, okay, so the probability of MCIS is what? Point 5. You guys even know what MCIS is? It's like the, they used to be like the senior wing, like you had to go, like half your day was spent down there. Were you guys in high school on that?
No. It's our freshman year.
It was a thing your freshman year?
Senior week.
Okay.
It stopped when we were going into our sophomore year. Yes. No, it stopped after our sophomore year because the class of 2021 was the last class to have it. Yeah.
Alright, and then the probability of AP stats and MCIS. Remember that upside down U, which kind of looks like an A, which is like the first letter of and, is helpful. 0.30. That was mind blowing, right? So then what I'm asked to find is the probability that they are in AP stats, given that they are in the MCIS. So what's the probability they're in AP stats if we know? So if we know it, it's given. They're in AP stats. So the formula is always the probability of both of those things divided by the probability of what you know or what was given. The formula is not bad. It's just a matter of like reading the question, realizing it's a given and a conditional, and like setting up this formula. So what's the probability of both? It's 0.3. The probability of the given is 0.5. So if you divide those, you get 0.6. Don't try number 2 yet. There's not enough information. Question on 1 though. So let's say in 2 that I gave you enough information. I also included that 20% of people own both. Now try number 2. Right? Nope, that's not enough. That's not enough people. 40% of people. So is that because they don't be better weekend performance, or like we don't know? Check it out. Someone play like sprain their ankle or something. That's very recent.
Suppose it's just like running hot.
Oh really?
Because of the character.
Because of the character.
Character shoes already like having everyone's that didn't help. But on top of that, also falling and stuff that
You mean everyone at Sage's feet hurt, or everyone? You said
I mean, by the end of the show, probably character shoes.
Character shoes. Oh, okay. Okay. Dang. Yeah, it is like a lot of feet are probably tired. What are characters? They're not comfortable. So it's always the probability of both divided by the probability of the given. So the probability of both here is 0.4, and then the probability of the given is the bike, and the bike is 0.75, and I don't know what that is, 8 over 15. What's that as a decimal? Nobody? None of you freaking divided it? Does that make sense? I got the number? Why you don't like please? Okay. You sure? Okay. So it's 0.533. Not that it matters. Try number 3's a little tougher. But try it. Three's a little bit trickier. Was the audience better than the student audience? They laughed a lot? That's gotta feel awesome.
They laugh at things you don't expect, so like you have to wait till they stop.
Oh, really?
It's like backstage you can laugh and it's like fun here. You just
Yeah.
laugh.
Because if you cut them off, then they'll stop laughing. It's gotta wait till it's done.
Yeah. So it's like interacting a little bit. Alright, so this one's a little tougher. Just because you're working it backwards. If I write out the whole formula first, I think it might be easier to see. So I'm looking at studying and past, and what I know is that I studied. So the probability that I pass, let's do the probability of pass given study equals the probability of pass and study, which is both, over the probability of the second thing, the one that's given. So this is like an equation that I have to work on both sides. So what's the probability that I pass given that I study? It's 0.8. Like you're not having to find that this time. And they're telling you that piece of it. So this part's 0.8. And then the probability of both that you studied and passed is 0.7. The probability of study is what I'm looking for. So that's like my x. And then I would probably throw this over 1 and cross multiply. Like 0.8x equals 0.7. So fraction equals fraction, you can always do that. Cross multiply. So the two things equal. And then if you divide by 0.8, this comes out to, Aaron, what's it come out to? 0.875. Notice something else too. This is just like a little algebra trick. I had 0.8 equals 0.7 over x. And at the end of it, what I ended up with is x equals 0.7 over 0.8. Really, what happened there? If you're in that spot, you can just switch those two. Which is like a little quick algebra trick. If I have like 6 equals 12 over x, say, like don't even do the algebra, just look at that. What's that? 2, 12 divided by 2, right? Well, if I just switch those, doesn't that tell me x equals 12 over 6? Which is 2. So it's just like a little shortcut trick you can use. Questions on 3? Avery, why are you laughing at me?
Because I did it really wrong and then I got the right answer still somehow.
You got 0.875?
I put 0.7 over 0.8 and then just divided into it and I still got the same. Yeah.
That's what that is.
Yeah, but why did you do the whole thing?
The cross multiply piece?
Yeah. Why did you make it? Why did that?
Like the formula? Well, how did you know what, like,
I just read it and I put it
You
in
know,
a
put
spot.
0.8 over 0.7 because then it's greater than 0.7 over 0.8. Those are the only two numbers they give you.
But also, like,
If I was confused
No,
on
no, I
test,
mean-
I would have necessarily complicated.
but like what if there was a third number there? Would you know what to do?
Yeah, probably.
like, this is algebra class, I give you that, what are you gonna do? Right?
I think about it.
So I'm just like, there's actually like math in here. So, yeah, no, that throws you off.
No, this is just putting numbers in the right place.
Okay. Good luck with that. Try 4 and 5. There's 3 numbers now, so what are you gonna do? Cross multiply what? Just put 3 things in an X in there randomly and see. So there is in each one of those like a number that you don't need. It looks super horrible. Am I good or everyone? We're good? Alright, so the probability of snow given that it is less than 32 degrees. So it's the probability of snow given less than 32. So I know this, and I want to know the probability that it snows. So the probability of both of those things divided by the probability of what you know. So the probability of less than 32. So what's the probability of both? 0.2. The probability of less than 32 is 0.6. So that's 1/3 or 0.3333. Sound okay? It works when you don't have. You got 3 numbers. We're still good.
Yes.
Pass given that you study. So this is number 5. Pass given study. So that's the probability of both passing and studying divided by the probability of study. So the probability of both is 0.4. The probability of studying is 0.7. Aaron? Oh, my bad. I was so excited to find out what the decimal was. Probability of both. Wait.
It's 4/5.
Oh, studying is 0.5. Yeah, yeah. Well, then I don't need it anymore. No. So it's 0.8. So it's the probability of both on top and the probability of studying, because that's what we know was the bottom. I put the wrong number in on that. Is that okay? You know why I put those numbers in? What? Okay, let's go through 6. Yeah. So I'm trying to make a point here. So the probability that it rains today, given that I wear a blue shirt. Probability of rain given blue. So that would be the probability of rain in blue over the probability of blue. Or you can write it like the probability of both divided by the probability of given, whichever you want. So the probability of both is 0.24. What's the probability I wear a blue shirt? 0.6. If you divide those, you get 0.4. It says what? Oh, that's not a question. question you say. Thanks, Avery. Okay. What is the probability that it rains? Don't think too hard. 0.4. So, this is what independence is. If I know the probability that it rains today, it's 40% chance it rains today, right? Well, now I tell you that I wore a blue shirt today. Does that have anything to do with the probability that it's going to rain? No. So that's independent. And we know it has nothing to do with it because when I told you I wore a blue shirt, the chance of rain was 40%. When I didn't tell you I wore a blue shirt, the chance of rain was 40%. So was the blue shirt relevant in any way? No. So that's what independent is. One thing that has absolutely nothing to do with it. Okay. So we can do this the other way too. So find the blue shirt, find the probability of blue shirt given that it rains. So that would be the probability of, well, now it's not R and B anymore. It's BR. That's the same thing, I guess. Over the probability of rain. So the probability of both is 0.24. What's the probability of rains? 0.4. If I divide those, I get 0.6. Well, what was the probability of blue before I knew that it was going to rain today? 0.6. What's the probability of blue after I know it's going to rain today? 0.6. So what do we know about a blue shirt and rain? Independent. They're unrelated. They have nothing to do with each other. So the events are independence. Question on that one? That's it. These last few here. A little tricky. Alright, what does mutually exclusive mean? That happen at the same time. There's no overlap. If you did a Venn diagram, your circles would not intersect. So it would look like that. So like this might be AP stats first hour. This might be biology first hour. There is no overlap. You can't be in both those classes first hour. So if those two events are mutually exclusive, there can't be any overlap. Don't shout it out yet, but try these two. Try 7. Think about that Venn diagram. Think about those things. Try 7. If you can't, I'll wait. Give them a shot. So, probability of A given B. So what that means is I know B is true. So I know that I am in the B circle. If I know I'm in the B circle, what's the probability that I'm in the A circle? 0. So that's like saying I know you're in AP stats first hour. What's the probability you're in biology first hour? It's 0, right? Because there's no overlap. You can't be in both. So that one's 0. And then 8, well, what does that symbol mean? And so the probability of A and B is the probability I'm in both. But mutually exclusive means you can't be in both. So what's the probability we're in both? 0. Those two okay? Alright, number 9. I give you A, I give you B, and I tell you they're independent. So one thing has nothing to do the other. So let's jump to part B first. I'll do part A after. So they're independent, remember. So one event has nothing to do with the other. So the probability of A given B, if B has no impact, is the same as the probability of what? A in general. Because the B doesn't matter, because I'm telling you they're independent. So really, if they're independent, you could just do that. Because the given part makes no difference at all. And then the probability of A is just 0.5. So I know it's like not that tricky because we just did one, but if they're independent, which I'm telling you, what's the probability of B given A? 0.4, right? Because if they're independent, I can just cross off this part because the A doesn't matter. And I can just say, okay, it's that. Alright, 9A for and. What does and mean? We have or and. Two. Or means add, and means multiply. Both, yeah, both. Multiply. So the probability of A given A and B equals the probability of A times the probability of B. This is just those slots, basically, that we did yesterday. So you go 0.5, 0.4. That's 0.2. So okay for 7, 8, 9. Those are a little trickier, I think. Try 10 and 11 if you haven't on yet. Give me a minute, then I'll go through those two. Just start dividing numbers. See what happens. Where are they? That's not Howard. Oh, yeah. Sadie. There, Sadie. I just heard you. What's their grade?
No, I was talking about those two pictures.
Look at that, like a student work this way.
Yeah, that's what I was talking about. That's all I meant. Why didn't we get to do this last year?
Because your grade was able to graph a line without like 3 weeks of practice. So that was nice. Like one day we literally like they made the lines and stuff the one day, and then the second day everyone literally just colored it.
We could probably use that in 6 hours.
What?
We could probably use that in 6 hours.
Maybe.
So you guys have had grades on
Slope and y-intercept is
Don't worry, I'll
is
just
going
write for that.
to kill me. On a graph a line?
I don't even know.
Y equals MX plus B. That's like the easiest thing to get. Like, but like, once you're someone
Yeah,
will get me
like-
confusing, but like,
I don't know.
I don't think you understand the level of confusion
Oh,
though.
I
I know, I know.
But I'm saying, I'm just.
How do you log divide? Yeah, the show us how to log
I
divide.
know how to.
Oh,
Yeah, I forgot.
Absolutely.
I forgot how to do that.
So like, I don't know, tell me what to divide.
48 by, okay, 342 by 53. Well, maybe right.
Yeah, that's not a great example. Let's do 53 into like 6,010, let's say. So, alright, you got 53. Does 53 go into 6? No. Does it go into 60? Yes. How many times? You never had so much class participation before. So you do 1 times 53 is 53. Subtract those and you get 7. Bring down the 1. Does 53 go into 71?
Yeah.
You guys don't remember this? Oh my gosh.
This isn't how they teach it anymore.
This is how I learned.
We learned it.
By hours of practice.
3 times.
No, we did.
Whoa.
We just forgot.
Oh.
Wait, so what do you get?
Okay,
No, you're right.
Oh, yeah.
And then it,
The whole month.
no, it's you gotta do the desk and not the remainder.
I'm not gonna need a Google calculator for that.
Oh.
Yeah, I think we're all set with the learning. Can I finish 10 and 11? Shh. Let me do 10 and 11, please. So I got the given. I see this given, and that just, like, right away, and I'm pretty sure I'm going to be using that formula, so I'm going to write that down. Probability of A given B, probability of A and B over the probability of B. But they give me different parts. So the probability of A given B is 0.5. The probability of A and B is what I'm looking for. And then the probability of B is 0.3. So, again, mind-blowing algebra 1 lesson here, if you're ready. Throw that over 1. And if you have a fraction equal to a fraction, you cross multiply. Or, some of you might have just been like, I'm just going to multiply both sides by 0.3. That's the same thing. Did you get 0.15? Oh my god. Well, how do you know that that's what you're supposed to do? Well, last time there were just numbers you divided them.
You just know. I actually didn't know.
Does this strategy work for you on tests?
We haven't had
You
a
just
test on
know.
this yet.
Yeah,
Like,
that's what the test is for, so that you just know.
Well, because in the last problem we multiplied, so when we saw this simple thing, so I just
does it make sense what I'm actually doing?
yeah.
Okay.
I don't know if I would have gotten it
Okay, well then, like, maybe next time. Alright, so let's do 11. Again, I see that P of A given B formula. I see the P of A given B, so I'm going to write down the formula, and then I'm just going to go through and look at what they gave me. So this is 0.8. Probability of A and B is 0.7. And then the probability of B is looking for. So, like, if you didn't write that out, how do you know if you're multiplying or dividing? That's not a, no!
because
You don't! That's garbage. So did you have like 0.56 for this one? Some people. Maybe. It's not right. No, 0.56 is not right. But that's what, if you were just like, I just know I'm supposed to multiply.
oh wait, that would have been
That's what you would get. So I would put that over 1, cross multiply, or flip flop those. I think this is the same question as I gave you earlier. It's 0.875. I don't even know why I bothered teaching. You guys just know.
We've just learned so often. You're just such a number magician.
I needed that to be.
Now.
We should have a master.
Soon. You're almost there.
No, it's not there. I got like 6 years to go.
Other questions on any of that I can help with? Okay. That's all I got. So there's Kyle still rolling. Same thing Monday, we'll do a worksheet for like, how this amount, there's not going to be a test or anything before Thanksgiving, but pretty quickly after you come back. Not like the first day, but